Good morning, and this is Chemistry 2341, homework chapter 5, part 2. In this one, we wanted to use a model to help us understand what was going on in our system. So if we look at here at number A, right here, we're going to align this such that we have our model aligned so that we have everything kind of pointing in the correct direction. And in this case here, we're going to have to tilt it in this direction so that the purple ball here is the bromine and it's facing toward us. The hydrogen and the fluorine are the two other ones. And then the back one here is the methyl group. So we have that this is 1 because it's bromine, this is 2 because it's fluorine, this is 3 because it's methyl group. So we have 1, 2, 3, and that's counterclockwise. So if counterclockwise, that gives us, this is S right here. Okay, now we're going to take that same model and assign them the same way. We're going to have the hydrogen be the white sphere here. We now have methyl group going back right here, fluorine coming up, and the bromine coming out at us. Okay, so that means bromine is here, the fluorine is here, so bromine is here, fluorine is here, and then methyl is there. So that gives us also counterclockwise, which means it's S. So what that means is these two compounds are the same compound. They're just in different orientations. Okay, so let's do that again over here. And when we look at this one, we're going to look at this carbon here. We have this is our first priority. These two are the same. And because they're methyl groups here, so that means this is not chiral. This is achiral. Okay, but this one over here, let's look at this one. Oh, 2 hydrogens on it. This is also achiral. So those were fairly simple and straightforward to look for. Remember, you want to look for those 4 different things to make it a chiral or not chiral compound. Okay, so let's do this one right here. We're going to consider these pairs. And I guess I'm going to try to erase this right here. One of the things you can do here to see if they're the same is to look and see if they are mirror images of each other. So if we were to draw the mirror image of this one right here, it would be Cl, and then we would have the chair going this way, and the Cl would be there, and then the other Cl would be here. Okay, and if we turn that around, oh, Cl, if we rotated this around to see if it looks closer to that one, we can see that it is, let's see, if we rotate that around, boy, we're going to have a little trouble there. So we have 1 in the axial position and 1 in the equatorial position. And if we looked at this, well, we have to worry about whether or not it's going to go from one chair to the other chair. So if we were to take this one and draw it in the other chair position, we would have a Cl down here, right here on this one, but it's on that carbon there, and then this Cl would then be equatorial. So notice that this is actually going to be the same compound again, because this, when we go to the other chair conformation, those two are going to swap, and we're going to have them in the same 2 positions. Still 1, 2, 3, 1, 2, 3. They're in the 1, 3 positions, so they are going to be conformers. They are just conformers. They are not stereo at all. Okay, so now let's look at this one right here. So in this case here, we have diastereomers. Okay, why do I say we have diastereomers? Well, we have 2 chiral centers in each right here, and they're not mirror images of each other, so they can't be in enantiomers, okay? But because they have all the same connections, they must be diastereomers. Now, the other thing to note is that this diastereomer has a mirror plane. So this is a meso diastereomer, and this is the chiral diastereomer, okay? And if we wanted the other we wanted the enantiomer of this one, we just draw our mirror plane and do our drawing of our groups here, CLH and CH3. So these two would be enantiomers. These are diastereomers. Okay, next question. Okay, let's look at these. Consider these structures, designate the chirality. So we don't have anything chiral in this one and this one, but we have in this one, I think that these are both cis alkenes. And if we draw it flat, it's like this, but if we let it kind of, let me see how many carbons we have. 1, 2, 3, 4, 6, 7, 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8 carbons. So they are the same compound as well. They're just drawn in 2 different ways. Okay. In this one, these are also the same compound because if you just rotate this 90 degrees, it's going to look exactly like the other compound. So when we're looking for things, look for similarities and look for differences. And don't forget to count for 4 different things when we're assigning chirality. All right, now tell which of these compounds each are pairs of enantiomers, diastereomers, constitutional isomers are not isometric. Okay, so the first thing you want to look for are all the same things on here. We have a COH, we have a C2OH, and we have OHs. So these must be isomers. Okay, they have all the same groups here. And because they are not mirror images of each other, that makes these diastereomers. So I'm going to erase this line and write the word diastereomer. Diastereomer. Okay, these are diastereomers. Okay, so let's do the same thing here. Same, and all the same in the middle. So those are definitely isomers. And notice that they are mirror images of each other. So that means these are enantiomers. Enantiomers. Now let's do this over here. We have same groups here and all there. And they are also mirror images of each other. So these are also enantiomers. Okay, now we have the same groups, but they're on opposite sides. And we have all the same groups. But if we redraw this, we rotate this 180 degrees this way and this way, those OHs are going to end up on this side, and therefore it's going to be the exact same compound. So they are the same compound. Okay, so that's all of our questions for chapter 5. So go ahead and study these and practice those different ways to draw things. Remember, we have our 3-dimensional with wedges and stuff, and then we also have our Fisher projections here, which are really good for doing diastereomers. All right, thank you very much and see you soon.